First job is to check the alignment of the rear fixed vice jaw to the Z-axis. The needle is bearing on the back jaw. You notice practically no movement. I'll move the gauge to another position just to check. That's showing hardly any discrepancy from end to end on a 75mm vise. So I'm quite happy that that's aligned with the Z-axis. I now need to mount the workpiece, which is a 1-inch square, 25mm square, material EN8. Because I want to machine the Tslot, I'm putting a couple of parallels in the bottom of the vise to keep it above the job. And before tightening, I'm going to ensure that it's aligned to the left hand side of the vise jaws. Tap it down. The vise handle off. The top is marked with the positions of the V grooves to be cut, and the next thing to do is to tilt the vertical head to 45 degrees. Setting the head is achieved by aligning the side of the mill with an optical protractor set to 45 degrees. When it's set over to 45 degrees, you have to ensure that the table is able to move to both of the 45 degree cuts without failing. The tool to be used for the 45mm cuts is a 4-flute, rather well used Carbide end mill. We'll insert into the spindle, and I need to position the spindle in the X-traverse to be in line with the first Tslot, to the first V groove rather. This is done initially with a sighting by eye. And then set the cutter to revolve at a low RPM. Just keep tapping the head down by 0.1 of a millimetre increments till it starts to make a cut. It's just cutting on the corner of the teeth. Set the Z axis to 0 and raise the head up and check that we're on the mark. It appears to be aligned. Absolutely on the mark. I'll take it down to 0. I'll increase the speed and we'll put a small cut in. That's 0.2 of a millimetre. That will now give us a good indication of the alignment of the cutter to the mark. I'm happy that that's precise enough for this operation, so we'll bring the cutter down. I've set the cutter now so it's 1 millimetre above the surface. That's the most rearward point that we need the cutter to travel. So we'll set the Y axis to 0, bring it forward. And that's brought it forward 39 millimetres. So we now know that it's positioned in the x-axis at the correct point for the first V cut, and it's 1 millimetres above the surface of the work. We're now set up in a different position to enable me to bring the chip guard over. I've loaded the program into the machine. This is just a straightforward program using G-code. So I'll start the machine in motion. The depth of the first cut is 1.65 millimetres. The total depth has got to be 3.30 millimetres. It's cutting this from the front to the back. It does that It's only running at 30 millimeters per minute in the cutting pass, and it's now coming back at the same height as a clearance cut at 100 millimeters per minute. And once it's returned to the start point, it will lower the head down 1.65 millimeters to do the final cut depth. And this is again at 30 millimeters per minute, and the speed is set at 1050 RPM. Some vibration coming from the machine. I think the cutter is way past its best, but it seems to be okay on this material. Although it's EN8, it's quite tough. Probably the reason for the small amount of vibration. And you can see by that the V is now formed. That's the first V that engages on one of the corners of the tool post. The tool should now return as it did last time at 100 millimeters per minute. And it'll give a final clearing, a final cleaning to the groove. What it does then, it moves the axis 42 millimeters. And drops it down now. It's at -165 again to do the second V groove, which is going to do it the same cutting speed as before. You've seen it do it once, so we'll cut this until the final finish pass, when it'll come back to it again. What we have now set up is the tool block with 3 holes spotted, ready to drill through completely. There are 2 that in the sides of the Tslot to assist the cutting of the Tslot. There'll be less material to cut out, and also there's a hole to be drilled through for the tool block adjuster when it's mounted on the tool holder. I have a program loaded, it's all ready to go. It's all set up. Need to pull over the screen, press the button. I'll be adding lubricant manually. That's the 3 holes drilled and the tool bit returned to the start position. I'll close this now. I've got another one to do. Tool block is now set up to start the Tslot. There's a 10mm cutter installed. The program is loaded, it's all ready to go. Close the chip door, press the button and away we go. What it's doing is taking a 2mm depth of cut from front to back. The cutter is quite worn. It's only cutting to 9.74 width. So at the end of the 2 passes there will be a further pass to shave off each side of the slot to increase it to the necessary width. On this return pass, the cutter is only cutting 0.2 of a millimetre depth. That's to give clearance to the T-slot cutter when it's making the T-cut. It saves the cutter cutting the full width of the 16mm T-slot. It's now moved over to increase the width of the slot it's cut to what's specified, because the 10mm cutter, as I said earlier, is only cutting 9.74mm in width. I probably should have used a 10mm 2-flute cutter, slot drill, for cutting the slot, but I don't have one, so sometimes you have to use what you've got, and in this case it suits the purpose because I can clean up both edges to leave a fine finish. Now coming back to cut the side on the left as you view it. It's cutting off 0.73 of a mil. And that should end up with an 11mm wide slot. And then the tool will go back to a central position within the slot at the end of the program. That won't be changed then until the Tslot cutting tool is fitted. That's that part of the program completed. What I need to do now is to change the tool for the Tslot cutter. And it's cutting the Tslot. It's all set up, so we press the button and away we go. This is using a Woodruff cutter, not a Tslot cutter. The difference being that on the bottom face there aren't any teeth on the Woodruff cutter, where on a proper Tslot cutter you have teeth on the underside as well. That's the reason for making the central slot slightly deeper than the finished depth of the Tslot, so that the tool doesn't drag on the centre portion when it's passing through. Just reduces the load on the cutter. This is a 16mm by 4mm thick cutter, and it's running at about 900 RPM, and the feed rate is 30mm per minute. So it's quite slow. But the material is EN8, which is quite tough. It went through the full depth of the cut, and it's coming back cutting 1.1mm to give a total depth of 5.1mm. To take the Tslot, take the T-nuts on the quick change tool post. You can see that the cutter is clear of the workpiece. I'll manually raise the head. And we can try one of the T-nuts in the slot. It's a nice sliding fit with clearances, and it should be okay. See what's been achieved there. And what's left to do is the slot now for the tool. I'll make another setup and we'll come back to it. This is the setup for cutting the slot for the tool holder. Program is loaded and ready to run. Press the start button. It's using the same 10mm carbide cutter. The width of the slot will end up at 12.5. And the depth is 11.5. So it's on a cycle now where it's going to do several passes at the 2mm depth, and then another adjusting pass of 0.5mm less to complete the depth, and then the tool will come over to cut the finished width of the slot, because you remember the cutter is only cutting 9.74 wide. Fade out now and come back when it's almost completed. It's a bit boring watching the passes. The cutting is complete now. The machine is stopped. We'll remove the job from the chuck. It's not too hot to hold. And that's the finished slot. What's left to do now is to drill the 5mm M5 holes for the fixing screws, tool fixing screws. The width of the slot allows the use of 12mm square or 1/2 inch square tooling. I've got a mixture of each, so these cater for both sizes. Thanks for watching. Program is loaded now for drilling and tapping for the tool fixing screws. They're M5s. So the first job is to drill the 3 holes, 4.2mm. It's a 4.2mm stub drill in the chuck, just with one peck. No need to use the centre drill with the stub drill with that side anyhow. It keeps pretty straight. I add the cutting fluid by hand, saves making a huge mess with the studs running. I avoid using them whenever possible. Going back now for a tool change. It's rising up now, ready for this tool to be removed. You notice it's a quick change holder, BT30, SK30. Should now be at the right height for the tapping function. I need to manually change the spindle speed, drop it back down to 500. It's now positioned ready to tap, so I can hit the start button. It's removed, the tap has come away from the job, so I can press the start button again. It's positioned over the hole. It's removed from the hole, so we press the start again. Just add a little lube or a little cutting oil. Press the start. It's clear from the hole, so we press the start again. It's now coming back for a tool change. Remove the tapping head. And there we are. Those taps. Tapped M5. Thanks for watching.